Hi students, I hope you had a very good time with your physics paper. Definitely it was not, I would say, a very difficult paper. It was a well balanced paper, the physics paper today. So how many of you are expecting a score above 80%? Let me have your names on the chat box. Let's look at the first question. What do we have here in the first question? See, the question is not very difficult. It's rather very simple. Okay. What has been said that there is a charge Q which is uniformly distributed over the surface of a spherical shell of radius r. All right. So let me take, visual representation I think would be much better. So this is my spherical shell out here and it is having a radius r. Okay. It is having a radius r. Now, what will be the work in bringing a test charge Q naught from center to its surface? From center to the surface, from this point to this point. See, understand, what is the potential on the surface? What is the potential on the surface? It is given as your kq upon r. It is kq upon r, where charge Q is the entire charge over the surface of the spherical shell, right? What about this one? The potential at the center. See, the potential at the center will be same as that on the surface. So that is also equals to kq by r. So what is the potential difference? The potential difference is equal to 0. That means the work done we know, which is given out here, is q into delta v. If delta v is equal to 0, then work done will also be equal to 0. So how many of you got this right? How many of you have got this particular question right? Come on. Put up your hands out here. Awesome, awesome. Lot of you. This is not a very difficult question. Very easy. Let me tell you, this year the objective paper side was something which is very simple, isn't it? Don't you agree with me? Chalo, I think most of you should have scored above 80%, for this particular paper. Now, what do we have here? A Zener diode. A Zener diode, we know for sure, it is what? It is working on a reverse voltage principle, isn't it? So both the P side and the N side are equally doped and both are heavily doped, right? So which one do we have here? Option C as the correct answer. That is heavily doped N side as well as your P side. Okay, very simple students. Okay, chalo, let's move on to the next. I can just say the Zener diode as fabricated by heavily doped P and N side of the junction so as to, what are the reasons behind it? Push the conduction band very near to Fermi level so that it's like, very less, alright. Make depletion layer kind of narrow, as less as possible, and then making resistance lower and allow a large current to flow with little potential difference. So these are basically the three reasons. By the way, you don't have to write down all those things, just like your JEE mains or any other competitive examinations. If you simply choose your option C, you will get all your marks. What a blessing. Alright. Chalo, now let's move on to the next part. Now this is a important one. Okay. Let's look at it. I don't know how many of you have done this correctly, but it is not a very difficult question. Alright, we have two large conducting spheres carrying Q1 and Q2 are kept with their centers r distances apart. So I have got two spheres. This one is carrying a charge Q1. This one is carrying a charge how much? Q1. Alright, and this is carrying a charge equal to Q2. So let me say plus and it is all on the surface. It's all on the surface. Alright. Now, the magnitude of electrostatic force, though we know that we tell you people all the time, if I have two spherical charges, then I treat them as your point charges and find out the force of interaction between them using the Coulomb's law, that is K Q1 Q2 upon R square, right? But here in the question it is said that the force is not exactly equal to this. Okay, why? try and understand that these charges and these charges are going to repel each other. So the charge distribution is going to be more on this side, okay. It's like, you know, these charges will be like, you know, more moving towards this side. So charges on the sphere will shift towards the center of their respective spheres, alright. That means move more towards this side or towards this side, okay. Alright, as a result of which option C will be the correct answer. These are not point charges. Well, we treat them as point charges, so option A cannot be the correct answer. Charge distribution on the sphere is not uniform, okay. Charge distribution on the sphere is not uniform. Well, that is also shift to the center of their respective spheres. No, it's not option C, it's my mistake, okay. Option C will not be the correct answer, rather it will be option B, because the charge distribution on the sphere is not uniform, because here it says it is moving towards the center of the sphere. Well, the charges are not going to be moving anywhere closer to the center, it's only that they are going to be distributed on the surface itself, alright. And due to the uneven distribution of the charges, the forces cannot be written as 1 divided by 4 pi epsilon naught q1 q2 upon r square, alright. So I hope everybody has got it. Now we can move ahead to the next question, alright. Chalo, what do we have here? Now, this is a simple one. What do we have here? A charge plate is placed between the two plates of a charge parallel plate capacitor, okay. So we have seen what is a parallel plate capacitor looks like, isn't it? Now, a charge is placed in between them. It experiences a force F, right? If one of the plate is removed, then the force on the plate will be how much? Such a simple question, isn't it? Dekho, simple सी बात है. These are the two plates of a parallel plate capacitor. Now we know in between at any given point, electric field will be equal to sigma by 2 epsilon naught, that is due to this plate, and due to this plate it will be another sigma by 2 epsilon naught. So the total field in between the two plates, will be sigma by epsilon naught, okay. It will be sigma by epsilon naught. So the force experienced by this charge will be Q into E, that means it will be Q sigma by epsilon naught, alright. Acha, now simple idea, if one of the plate is removed, try and understand, if one of the plate is removed, then at that region wherever you had placed this particular charge, what would be the electric field at that point? The electric field will be sigma by 2 epsilon naught. So the force F dash can be written as Q sigma by 2 epsilon naught. So this is nothing but F divided by 2. It will be equal to F divided by 2. Alright. So option C here is the correct answer. Alright. Chalo, give me a cheer if you have got this particular question correctly. All of you, come on, give me a quick cheer if you have done this correctly. And yes, students, do not forget to press on the like buttons if you have understood the solution out here. And keep a pen and a paper ready so that you can keep on evaluating how much marks you have already scored. Because I am going to ask you students that who has scored the maximum for the ones who are watching us live on this particular platform. Alright. Chalo, let's move ahead to the next question, students. Okay. What do we have here? See, these are all theoretical questions, and if you have even given last effort to solve last 5 years paper, which I was telling you on this platform itself, alright, when we were discussing about how much of effort or how much you should be balancing between your JEE mains and the board examinations, I told you at that time, if you do your past 5 years papers, alright, all these questions, all these concepts have been repeated, okay. So that would have been a smart way to score really a very good marks in your board examinations, alright. Chalo guys, now let's move ahead to this. In Bohr's orbit of hydrogen atom, the total energy of electron in nth discrete orbit is proportional to what? Simple idea. Let us look at the expression. We know the expression is what? For total energy. To total energy, it is written as minus RCH Z square upon N square. So I can write here directly. It is proportional to what? 1 divided by N square. All right. Pretty theoretical this particular question was. How many of you have got this correct? Come on. Chalo, students, what I want is the energy level in the class to be high. If you have got it correctly, press on the button, all right, of like, first of all. Secondly, put it on the comment section. Yes, that we have got it. A wire of 16 ohm resistance. We have got a wire of 16 ohm resistance. So what will be the resistance of the top part? Top part and bottom part, both of them should have the same resistance. Don't you agree? So this part will have a resistance of 8 ohms. This will also have a resistance of 8 ohms. And what? They are in series or parallel? They are definitely in divided by 8 plus 8. That is 64 divided by 16. That will be equal to 4 ohms. Such a simple one, isn't it? All right. Students, if you are enjoying, do not forget to press on the like, share, subscribe, all right, because we have made it a point that to reach out to you on the day of the examination so that you can actually be at peace that these were the questions that I have got it correctly and these are the ones that I have not got it correctly, and then move ahead to the preparation of your chemistry examination, all right. So here we have our next question. Chalo, fine, let's move ahead to this. Now this is one of the very standard ones. These are very standard questions, okay. If someone has actually sat down and listened to the classes of last year at your JEE, all right, at Unacademy, I am sure if you were just listening, all right, I am sure anybody could have scored more than 70% in this particular paper. All the questions, similar things have been discussed in this particular channel itself, okay. So if you were actually, let's say you had come to the platform with even 30% seriousness, you could have scored more than 70% today in today's board examination. All right. Chalo, now let's move ahead and get to the solution of the remaining questions. बहुत lengthy paper था. What do you think? Was the paper lengthy, students? What is your suggestion? Was the paper lengthy? I would say I would give it a rating of lengthy with respect to the paper. It would be somewhere around 8 out of 10. Okay. 8 out of 10 is the rating for the lengthiness of the paper. Okay. Acha, chalo, let's look at this. There is a region which has got a uniform magnetic field. A proton enters into the region with velocity making an angle of 45 degree. Okay. Now, simple idea, all right, that it is not going along the direction of the field, rather it is making an angle of 45 degree with the direction of magnetic field. How will the proton move? Now, we know for sure that this is generally the way the proton is actually going to move, all right. When it enters at an angle, if it moves in the direction, then angle between the magnetic field and velocity is 0. That means no force is going to act. But if it is going in this particular direction, try and understand, if it is going in this particular direction, then one component of the force, all right, will kind of make it move in the forward direction, and the other component is making it move in a circular way, all right, as a result of which it is following a helical path. Okay, what is it following? It is following a helix, correct? Now these are all very easy questions, students. Okay, chalo, let's have a look at the next one. Now this is again related to the force, the effective force on a current carrying wire. The force on a current carrying wire placed in a magnetic field. I'm sure you have done a lot of questions with respect to this particular concept, and this question also is a very easy question. Okay, what do we have here? We have a isosceles triangle. See this, what we have here is a isosceles triangle. Okay, what did they tell us? That there is a current carrying loop PQR which is placed in a uniform magnetic field B, pointing along PR, So the magnetic field is acting in this particular direction. Alright. Acha. If the magnetic force acting on the arm PQ is F, so on this the magnetic force acting is equal to F. Alright. Then, by the way, in which direction, all that is actually not required, but we know that if the current, let's say, is flowing in this particular direction and magnetic field is in the upward direction, then we know the force is going to be coming out of the plane of the board, right? Current is flowing like this, magnetic field is in the upward direction, force will be in this direction. But we are only interested in what? We are only interested in the magnitude of this particular force, right? So, the magnitude of this force, okay, on PQ will be equal to what? It is I L effective into B, alright. Now, let's try and see this. What is the length of this part? Let's say the length of this particular part is L. So, I can write this as I L into B. ठीक है? Now, see, try and understand, this is L effective cross B, that means L effective B sin theta. Alright, L effective into B into sin theta. Now, here in this case, L is in this direction, B is in this direction. So, what is the angle in between them? Angle between them will be equal to how much? 90 degree, and sine of 90 degree will be equal to 1. Now, let us look at the force on QR. Let us look at the force on what? QR. So, the force on QR is equal to I. Now, L effective is the distance from this point to this point. How much will it be equal to? Root 2 times L. Root 2 times L, because this is the hypotenuse of this right angle triangle, isn't it? This is the hypotenuse of this right angle triangle. Acha, this will be into multiplied by magnetic field B, and what is the angle between the length and the magnetic field? It is going to be equal to this angle theta. It is an isosceles triangle, so this will be 45 degree. So this will also be 45 degree. If this is 45 degree, corresponding angles theta will also be 45 degrees. Alright. So I can write here B into sine of 45 degree. If you calculate it, it will be I root 2L into B into 1 divided by root 2. Root 2 will cancel. ILB, that means it will also be equal to F. Alright, simple. So, option A is the correct answer. Alright students, chalo, I hope all of you have done so far really good in the paper, okay. Just give me a second. Okay. Okay, great. Anas Kabir, you have matched all the answers. That is superb. Okay. Live show nahi kar rahe. We are actually live, by the way. Alright. So you can interact as much as possible with me during this particular show. Fine enough. I think let's move ahead now to the next question. What do we have here in the next question? Let's see. What do we have here in the next question? By the way, the electric flux emerging out from 1 coulomb charge. The electric flux emerging out from 1 coulomb charge. How do we find it out? Okay. We know flux. Flux is equal to what? Gauss law. The first and the foremost thing that we learn in the Gauss law. What is it? Flux is equals to the charge enclosed upon epsilon naught. Such a simple one. So it is equal to charge enclosed upon epsilon naught, and charge enclosed is how much, students? 1 coulomb they have given us in the question. Okay, so this will be equal to 1 divided by epsilon naught. This is my answer, simple one. So option A is the correct one. Students, I think you should have got all the questions correct by now. Okay, these are not very difficult, not very in-depth concept also, just surface level. Maybe if you had studied properly, surface level, all right, even if you had not got down deep into the subject, even then all the objective questions are so easy, all right. But I am sure all of you have got these correctly. All right, chalo guys, let's move ahead to the next question. Acha, what do we have here in this particular question? It's rather very simple. Let me see, what do we have here? Acha, by the way, answer is going to be equal to mobility, right? Now mobility is equal to what? Drift velocity divided by electric field. Acha, electric field is equal to what? Potential divided by distance, potential difference divided by distance. So mu, what can I write mu as? Vd. Vd is what? Drift velocity divided by potential into d. What is the unit of drift velocity? Drift velocity meter per second, right? Simple idea. This is voltage, so volt and meter. If you solve it, you will get meter square per volt per second. Correct answer is mobility. So here in this question, I believe the formula for mobility was what was important. That is, it is the drift velocity per unit electric field. So if you knew this particular formula, the question was not very difficult. All right, chalo, let's go to the next question now. This is rather a very simple question which has come from wave optics, right? The shape of the wavefront originating from a point source of light. We know this is like very basic. If it is a point source of light, then the wave fronts are going to be what? Spherical in nature. That's a simple one. Now here we have a question from photoelectric effect. What is the question? It says the light of frequency sigma, mu, is incident on a photosensitive surface of threshold frequency mu naught. All right, mu greater than mu naught. The value of kinetic energy of the emitted photoelectrons is going to be how much? Now this is such a simple question based on the formula of your Einstein's photoelectric equation. What does the Einstein's photoelectric equation tell us? Simple. It says the energy incident. If you take any surface and photons are coming and striking this particular surface, then the energy incident will be h mu. That is, this is the incident frequency, right? Now this will have certain amount of threshold due to which the electron is going to be liberated. Now this threshold energy is given as your h mu naught. All right. Now as per the formula of Einstein's photoelectric equation, we have the energy incident is equal to the threshold energy, that is equal to h into mu naught plus kinetic energy. All right. So the kinetic energy is the difference of the energy incident and the threshold. Simple enough. So from this data, I can write down my kinetic energy as equal to h times mu minus mu naught, and that is your answer. Okay, such a simple solution that we have here. Chalo, let's move ahead to the next question, dear students. All right. Okay, now you had a choice, either do that or do this. I would have done this anyways. It's just a single word that I have to introduce here, isn't it? What is the question? In photoelectric effect, the number of emitted photoelectrons is proportional to what? See, simple idea. More the number of photons which are going to come and strike the surface, more will be the number of photoelectrons that are going to be liberated, right? So more the number of photons means what? That greater the intensity of the incident light, more will be the photoelectrons emitted from the surface. So here the answer is intensity. That is your answer. Okay. Chalo, let's move ahead to the next question. Now, what do we have here? In Young's double slit experiment, we all have done Young's double slit experiment in your wave optics, isn't it? Now, in Young's double slit experiment, if the monochromatic source of light is replaced by another monochromatic source of shorter wavelength, then what will happen to the fringe width? By the way, we all know what is the formula of fringe width. Fringe width formula is equal to how much? It is equal to lambda capital D by small d. When you are changing the light from one monochromatic light to another monochromatic light, what are you doing? You are changing what? Lambda. This time, what did you do? See, beta or fringe width is directly proportional to lambda. So, you are replacing by another monochromatic source of shorter wavelength. So, lambda is decreasing. If lambda is decreasing, then beta, the value of beta will also decrease. Alright, simple enough. Now, let's go on to the next one. What do we have in the next one? Okay, now this is a little bit of a challenging question, isn't it? Did you face challenge in this particular question? By the way, how many of you have got this one correctly? Guys, all of you are having a good time trying to understand, but I don't see the number of likes coming up in the show. Okay, students, try and understand the efforts the teachers have been making in order to get all of these live on the same date of the examination. Come on, I want to see the number of likes increase. Let's target 100 in this particular next 15 minutes. Okay, in 15 minutes the number of likes should go up to 100. Come on, guys. Chalo, let's move ahead to this question here. The refractive index of the material of a converging lens is 1.5. Okay, so let me take a converging lens out here. Now, the material is 1.5. The refractive index of the material of this converging lens is 1.5. If the air is replaced by a refractive index of 1.6, right? Now, see, try and understand that 1 divided by focal length is given as mu2 by mu1 minus 1 into 1 divided by R1 minus 1 divided by R2. We know this is my lens formula, lens maker formula, okay, where I determine the focal length of the lens as per the refractive index of the material with respect to the surrounding medium, that is mu2 is the refractive index of the lens, mu1 is the refractive index of the surrounding material medium minus 1, and these are the parameters of the lens. Okay. Acha, when it is air, then mu1 is equal to 1 and mu2 is equal to 1.5. So, 1.5 divided by 1 will be equal to 1.5 and 1.5 minus 1 will be a positive value. That means focal length is going to come out to positive. If focal length is positive, it is supposed to be what? It is supposed to be a converging lens, right? Or a biconvex lens or a converging lens, isn't it? Now, if it is replaced by a medium of refractive index 1.6, then the lens will now behave as a what? This has to be going a little bit out here. Okay. By the way, if the surrounding medium is 1.6, that means mu1 has become 1.6 and mu2 is still 1.5. So, 1.5 divided by 1.6 will be a value lesser than 1. That means this entire part will become negative. If this entire part becomes negative, then focal length will also be equal to negative. If focal length is negative, then it is going to be a diverging lens, simple one. Okay. Chalo, students, let's move ahead to the next question. Okay. Well, that is the discussion that we already had. Okay. Now, this is again a formula based question on the section of polarization, right? If you have done polarization clearly, we know that there are different methods of actually polarizing a light, and you can do it by making it pass through a glass slab, right, where some part gets reflected and other parts gets refracted, right. Now the part which gets reflected will have lights oscillating in a different plane as compared to the ones which are getting refracted. Now from there we had the formula that refractive index of the material of the slab through which the light gets refracted is given as mu equals to tan of the Brewster's angle, okay, that is pi by 3. So tan of pi by 3 is 60, tan 60 is equal to root 3, that is the refractive index of the material, okay. Chalo, next question right away in front of you. What is the value of the power factor of a series LCR circuit at resonance? Okay, what happens at resonance? At resonance we know Z is equal to R and power factor is equals to R divided by Z. Power factor is equal to R divided by Z. So at resonance R is equal to Z. So R by R will be equal to 1. So cos of phi, that is your power factor, will be equal to 1. Okay. Chalo, next question. Next question, what do we have here? So this is what we have. In which orientation of the armature coil of a AC generator relative to magnetic field will the induced EMF be maximum? Okay, all of us know this. Increasing the angle between V and B, EMF is maximum when angle is 90 degree. Now see, I mean, like, you know, you have to probably write down all of these statements but also support it with a formula, that is your E is equal to E naught sine of omega t. We know definitely that this is going to be maximum. Maximum means what? That it will have a value of E naught. When will it have a value of E naught? When my sine of omega t is going to be maximum. When does sine of omega t becomes maximum? When it is at 90 degrees with respect to each other. Alright. So 90 degrees should be the angle of the armature with respect to the magnetic field for the EMF to be maximum. Okay. Chalo, moving ahead to the next question. Now this is one of the very standard question. This is like, you know, highly theoretical question. Okay. There is nothing much to discuss in this particular thing, but if you are aware of it, this is just a snapshot of whatever his contribution is in the field of electromagnetic waves. It has been presented out here. So at your leisure, I would suggest that you can actually read through this, isn't it? Chalo, let's look at this question. So guys, any queries so far? Any queries so far that you would want me to address beside whatever we are doing right now? How was your experience, by the way? How was your experience? Let me know from you guys. How did you find out the paper? Did you find it easy, medium, difficult? What is your perspective, students? Let me have a look at the chat box right away. What is your perspective? How was the paper like? Okay, awesome. Chalo, let's move ahead. Let's go to this particular question here. It says, in a AC circuit. So I think most of the students have mentioned that it is actually average paper. That is, the level of the paper was medium. It was not so easy, not very difficult also, right? So you have a very good chance of really scoring high in the board's paper. The pattern of the same physics type of a paper will be for chemistry and mathematics also, short answer questions, and like, you know, and you must have understood that the level is not going to be like very high or like too high. Okay, so if you have done things even at the surface level, also the point is, if you have done your NCERT like really nicely, okay, and just gone through the theory of your NCERT, I mean, you should have scored pretty well. Okay, chalo, let's have a look at this particular question here. In an AC circuit, the applied voltage and the flowing current are E equals to E naught sine omega t and I equals to I naught sine omega t plus pi by 2. So what is the phase difference between the voltage and the current? The phase difference is how much? Pi by 2. Simple, right? What is the average power consumed in one cycle in the circuit? Now P average is equal to what? Vrms into Irms into cos of phi. Phi is nothing but the phase difference, right? But phase difference is how much here? Phase difference is equal to 90 degree. Phase difference is equal to 90 degree. So cos of 90 degree will be equal to how much? 0. So average power will be equal to how much? 0. Simple one. Okay. Chalo. Let's have a look at this. What happens when a block of metal is kept in a varying magnetic field? Acha, try and understand varying magnetic field. Varying magnetic field, they produce electric field, right? Varying magnetic field, they produce electric field, and this electric field is circular in nature. It's circular in nature, right? These are not the electric fields which is due to a point charge or let's say a charge distribution. So these are circular electric field that gets created. So eddy currents are going to be generated around the metal block. Simple idea. So let's go to the next question here. Now that's what the concept that I was talking to you about. So eddy current is going to be generated, and yes, induced current, thermal energy, damping, and then electromagnetic damping leading to cut slots in the metal. So that is like, you know, the final picture that should be very, very clear for you students. Okay. All right. Let's have a look at this. This is not a very, very difficult question. We are all aware of this, isn't it? Everybody, whenever we walk out to the sun, we are supposed to be protected from the UV rays, right? Now, what is the radiation of the UV rays? It is 10 nanometer to 400 nanometer. Simple one, isn't it? Okay. Chalo, now let's have a look at this question itself. The number of densities of 3 electrons in the 3 conductors X, Y, Z are in the ratio. Now, what is it? The number of densities that we are talking about? Remember, in the formula, I is equal to NeAVD. Alright, we have this N. This is the number density that we are talking about here. This is the number density that we are talking about here. Okay, that is in the ratio 4:1:8. That is in the ratio 4:1:8, and the electrical conductivities are in the ratio 2:1:2. Okay. For which conductor will the relaxation time of free electrons be maximum and which will be minimum? Okay. Now, how do you go about this question? Let's have a look. We know I is equal to, this idea is simple. I is NeAVD, right? So I can write I divided as your NeVD. Then can I write J as also equal to sigma into E? Correct? Fine. Now try and understand this. What is VD? VD. See, simple idea. Let's say between two collisions, let's say an electron is moving and it is subjected to an electric field of E. It is subjected to an electric field of E. Then what will be the force experienced by this electron? The force experienced by the electron will be equal to E into capital E, right? So what will be the acceleration? E capital E upon m. That will be the acceleration of the electron, and if it is moved for time t, then Vd as per the formula V equals to U plus At. As per the formula V equals to U plus At, you will have Vd as equal to E by m into tau. Okay, what are you going to do? We are going to replace it out here, right? So we get J by Ne as equal to Vd into tau. Fine. So when we put this, we get the value of tau, and then when we take the ratio, it will be the ratio of nothing but sigma by n. Sigma by n. So you take 2 by 4, 1 by 1, 2 by 8. The ratio is 4:8:2. The relaxation time is in the ratio 4:8:2. Get it? That means we have the maximum for which one? The Y, and the minimum will be for equal to Z. Get it? Chalo, we will spend a little snapshot once again. I mean, we'll spend a little more time into this particular section. Got this particular point? Okay, that is, you have J by NE. J by NE is equal to VD. Okay, now what is VD? VD, I can write it as E into J upon sigma times M, alright, into tau. So, tau will become equal to what? Sigma by N M by E square. So, students, do one thing simple, pause your screen for 2 minutes, okay, take a snapshot of this, go through it, you will clearly understand. It's not a very difficult question, okay. Chalo, let's go ahead to the next one. What do we have here? A converging lens, simple question. A converging lens of focal length f1 is placed coaxially in contact with a diverging lens of focal length f2. So, I have got two lenses. One has a focal length of f1, the other has a focal length of f2. ठीक है, f1 is greater than f2, right? Determine the power. Okay, by the way, the first lens is converging and the second one is what? Diverging. The first one is converging, the second one is diverging. Understand, for converging, focal length is positive. For diverging, the focal length is negative. Okay. So, what will be the power of the combination of these two lenses? The power of the combination of these two lenses. See, simple idea. This was one lens, this was other lens. This is having a focal length of f1, this is having a focal length of f2. Okay. Now, come back to this point here. What will be the total power? P1 plus P2, simple formula. By the way, P1 will be 1 by F1, but P2 will be minus 1 by F2. Why? Because it's a diverging lens. So, if you put down here, power will be F2 minus F1 divided by F1, F2. That is the correct answer. Alright. Okay, students. So, this is the last question that we are going to take before the break. And after the break, students, Indrajit sir is going to be with you discussing the rest of the paper with you students. Fine enough? So, how is the resolving power for compound microscope affected if the wavelength of the light is decreased? See, resolving power is inversely proportional to the wavelength. So, if you decrease the wavelength, the resolving power is going to increase. Alright. Acha. Next thing, the resolving power of the compound microscope, the diameter of the objective length is increased. So, it is directly proportional to the diameter. You increase the diameter, the resolving power is going to increase. Okay. So, students, the rest of the questions, okay, is going to be discussed with Indrajit sir. So, we are going to take a very short break right now. And after the break, we will continue with our paper discussion. So, students, if you have enjoyed the session, do not forget to press on the like, share, subscribe so that these solutions can reach out to millions of students across the country. Thank you very much.
Long years ago, we made a tryst with destiny, and now the time comes when we shall redeem our pledge. India will awake to life and freedom.
चल उठ जा, let's crack it, जोर दे लगा, let's crack it, भीड़ को छोड़ दे, let's crack it, रास्ते मोड़ दे, let's crack it, चल उठ जा, let's crack it, जोर दे लगा, let's crack it, भीड़ को छोड़ दे, let's crack it, रास्ते मोड़ दे, let's crack it.
साधारण सी है ये बात, परीक्षा करनी है पास, रोक के रखना अपनी सांस, अपनी एक ही आस पीछे सारे मंत्र और रट ले सारे फॉर्मूले, जब तक पार लगे ना नहीं है तब तक रेस्ट ना तू ले, तो इस बार तू आड़ दे, 6 फुट अंदर गाड़ दे, आसमां को फाड़ दे, जोर से दहाड़ दे, अंदर की आवाज सुन जो तेरे भीतर आई है, जोर लगा तो जोर लगा, लड़ जरा कुछ कर दिखा, लड़ जरा कुछ कर दिखा, जोर लगा तो जोर लगा, लड़ जरा कुछ कर दिखा, तू काने है बड़ी इनकी भोगते बड़ा भारी है, भीगा है पकवान इनका शिक्षा के व्यापारी है, एक नंबर तेरा काम फीस यहाँ बहुत ज्यादा है, तू बाकियों से पीछे है, तू देख कितना नीचे है, उसके बाप का सिक्का चलता है, तेरा बाप कमाता सिक्के है, मत सुन इनकी ये धुन इनकी, तू बढ़ता जा बस लड़ता जा, क्रैक करते जा, जोर लगा तो जोर लगा, लड़ जरा कुछ कर दिखा.
जोर दे लगा, let's crack it, भीड़ को छोड़ दे, let's crack it, रास्ते मोड़ दे, let's crack it, चल उठ जा, let's crack it, जोर दे लगा, let's crack it, भीड़ को छोड़ दे, let's crack it, रास्ते मोड़ दे, let's crack it.
बेटा सिस्टम का ये बढ़ते जा, हिम्मत नहीं हार, सबको करके दिखा। क्या तेरा भाई तेरा दोस्त इससे बोल रहा, कर दिखा, लड़के दिखा।
Hello students, Sat Sri Akal and Namaste from my side. How are you all? How are you? Hope so. I can't say hope so. Yes, you all are fine because your boards paper have gone very awesome. Okay, bachcha ji. Okay, guys. So moving from here, we will resume from the 23rd number question. Right, as you all know, the discussion of the boards paper of the physics that went on today is going on. Okay, guys. See, the question states that define the SI unit of the self-inductance. See, guys. Before moving on to this question, guys, I need 1000+ likes. So those the students who are present here right now, just press the like button, bachcha ji. Just press the like button. Okay, guys. So moving forward to the question, define the SI unit of the self-inductance. The self-inductance of a solenoid is L. If the number of the turns, see, first of all, we will define the SI unit of the self-inductance. It is very simple. The Henry is the SI unit of the self-inductance, bachcha ji. The Henry, and it is named behind the name of the scientist. Okay, bachcha ji. So now, if the number of the turns per unit length in it is doubled, see, suppose initially N1 was N, again N2 was doubled, right? Twice of N1, right? And the area of cross section is halved. A1 is equal to A and A2, that is equal to A by 2, or you can say A1 by 2. Then find the new inductance of the solenoid. Find the new inductance of the solenoid. Okay, guys, moving forward to the very simple explanation. See, guys, if I'm talking about the self-inductance of the solenoid, whatever the EMF produced, that is equal to minus N d phi by dt. The change in flux with respect to the time. Now, flux is given as a magnetic field into the area. Area is a pi r square, and according to the Ampere's circuital law, the magnetic field is given as mu 0 n I. So, very simple explanation. Now, if we want to find the EMF into the each turn, then E is equal to minus d phi by dt, and replacing the value of the flux in this equation, we got this specific expression. Now, the total EMF, we are getting this, and by comparing to this equation, I am getting the self-inductance as mu 0 n square pi r square L. Right? A very simple explanation of the self-inductance. Okay, guys, see now how to move forward. See, we have seen into the data now. The N1 is equal to N and N2 is equal to twice of N1. Similarly, area A1 is equal to A. A2 is equal to half of the previous area. So we are getting the solution as using this equation 2 times. I am getting the L is equal to 12. Right? Haina. Okay. So initially the inductance was L. After that it changes to the twice of L. This is a very simplest explanation. Okay, guys. So this was the question number 23. Now moving forward to the next question. Okay. The question number 24. I know whatever the feelings right now we are flowing with you in your mind about this paper. Right? Hi, Anna. Okay, but it is not that much difficult as what we are thinking. Okay, I know some of the tricky parts are that, but it is not that much difficult at what we are thinking. Guys, okay, so those who are student present here, guys, can I have the likes button please? Fast. Can I have the likes button? Yes, definitely. Okay, guys, moving forward to the next part. A hydrogen atom is in third excited state. I am repeating. The hydrogen atom is in its third exciting state. The ground state N is equal to 0. First N is equal to, ground state N is equal to 1. The first excited state N is equal to T. Like the third excited state is equal to N is equal to 4. What would be the third excited state? N is equal to 4. See, here we are having the questions. Right? Here we are having the, see, this is the ground state. N is equal to 2. This is the first excited state. N is equal to 3. Okay. It's the second excited state and N is equal to 4. What we have to find? We have to find the transition. Okay, what we have to, how many spectral lines can be emitted by it? We are having the direct formula of the spectral lines, bachaji. We are having the direct formula of the spectral lines, right? So what is that formula? N is equal to N into N minus, see now, N would be the number of this state, the value, the number of this state. What is it? N is equal to 4, it is my third excited state. So replacing the value as 4 into 4 minus 1 by 2, my answer is equal to 6. The total number of this 6 spectral lines are emitted. Right, bacha ji? 6 spectral lines are emitted. Okay, guys? Okay, hope so this question is completely clear. It is in your mind. Right, it has been completely clear. Now moving forward to the next question. See, okay, how does an oscillating charge radiate an electromagnetic wave? Give the relation between the frequency of the radiated wave and the frequency of a oscillating wave. See guys, simple. I'm giving you the simple explanation. See guys, this is a charge. It is oscillating with respect to the mean position. Down, up, to, fro, to, fro, to, fro, to, fro, to, fro, to, fro. Right guys? So if it is making a motion kind of a to fro, right, and obviously it would be an obvious situation, then it would emit a radiation of the wavelength lambda. It would emit a radiation of the wavelength lambda. So guys, in that case, right, see, electromagnetic waves are the electric and magnetic field traveling through the empty space with the speed of the light. See, right? See, it's a very simple explanation. You don't have to worry about it. See, and accelerating, see, it is directly in NCERT. You can see to the blue background, na? It is directly in NCERT written, right? Directly it's from a NCERT line. An accelerating charge produces the electromagnetic waves, and electric charge oscillating harmonically with the frequency produces the electromagnetic waves of the same frequency directly from the NCERT line. Guys, those who are present here, can I have the 1000+ likes immediately bacha ji? Okay, thank you very much. Okay, see, very simple explanation. If it is oscillating with the frequency f, then same amount of the radiations with the same frequency are going to emit as because of its oscillation. Okay, as because of its oscillation. So it is directly from the NCERT line. So the frequency of the oscillation would be equivalent to the frequency of the emitted radiation. Frequency of oscillation would be equivalent to the frequency of the emitted radiation. Okay guys, right? See, now explain briefly the fact that electromagnetic waves carry energy. A very simple explanation behind it. See, electromagnetic waves bring energy into the system by virtue of electric and magnetic fields. As because of electric and magnetic fields, right, the electromagnetic waves brings energy into them, and this field exerts the force on them so that work can be done. So later on doing that specific work, some of the energy is consumed, some of their energy is absorbed, and the field strengths are diminished, and anything left travels on. So this is our explanation, right? Okay, this is our explanation. See, now why do we not feel the pressure due to the sunshine? See, if I'm talking about a sunshine, right, then that light is of the specific wavelength lambda, right? If I'm reminding you the formula of the radiation pressure, right, so replacing all those specific value, we are having the value of the radiation pressure, it is to be quite small, because we are considering the velocity of the sunlight. It would be equivalent to the speed of the light. Velocity of the sunlight would be equivalent to velocity of the light. So guys, according to this, if we are replacing some specific values, we are getting the very less value of the radiation pressure. We are having the very less values of the radiation pressure. So as because of that less value of the radiation pressure, we are not feeling any kind of the pressure due to the sunlight on the skin. We are not feeling any kind of the pressure due to the sunlight. Okay guys, so this is also another explanation, right? See, sinusoidally varying magnetic field associated with the electric field perpendicular to it. See, this is an equation of the magnetic field, right? Such combination of the mutual perpendicular electric and magnetic field is referred to as electromagnetic wave into the vacuum. This is a kind of the description of the electromagnetic wave into the vacuum. It carries an electric and magnetic field both into the perpendicular direction, like this way, right? Like this way it travels, like this way it travels. Okay guys, like this way it travels. Okay guys, moving forward to the next part. In what ways the matter waves, next question bacha ji, right? In what ways are the matter waves different from the electromagnetic waves? A very simple explanation. Okay guys, can I have the likes from your side? Can I have the likes bacha ji from your side? Okay, nice. Okay, see, Very simple explanation. See, we are having the spatial difference between the electromagnetic waves and the matter waves. We are having the difference between the electromagnetic waves and the matter waves. See, these waves have the electric and magnetic fields. EM waves are having both electric and magnetic fields, but the matter waves have no electric field and magnetic field associated with them. Matter waves, no electric field and magnetic field. Electromagnetic waves, yes, electric field and magnetic field. Okay guys, see, now these waves can easily pass through vacuum, but these waves can't easily pass through the vacuum, right? The next point, these waves have the fixed velocities. Matter waves have the velocity less than the velocity of the light, and depending on the medium or the situation. Depending on the medium or the situation. Okay guys, next point, wavelength of these waves can be measured easily, and the this wavelength of the matter waves we can't measure it easily, and these rays are emitted from a source in space. Whether these waves are associated with the material particles, they do not exist without material particles, and the final energy of these waves are quantized, and here the energy is not quantized. Energy of the electromagnetic wave is quantized because it is traveled, it is what we can say, it is sent into the form of the packets. It is sent into the form of the packet. What Einstein states that whatever the energy is transferred from one point to another point, it is transferred into the form of the quantas. The quantas are the packets of the energy. The quantas are packet of the energy. Okay guys, according to the Einstein, it has been written, right, by him only. What? From point A to point B, if energy is transferred by means of this kind of the waves, then they are transferred into the form of the small packets, and those packets are known as quantas. Those packets are known as what? Quantas. Okay guys, so moving forward to the next question, in what ways are matter waves different from the electromagnetic, and the kinetic energy of the particle is reduced to, see now, this we have discussed. Now moving forward to the B part, if the kinetic energy of the particle is reduced to 1/4 of its initial value, see, kinetic energy K1 is equal to K, and second kinetic energy K2 is equal to K by 4. Then how many times the de Broglie wavelength associated with it will become? Very simple explanation. What is the relation between the de Broglie wavelength and the kinetic energy? Yes, we are having lambda is equal to h by under root of 2m by k. So lambda is inversely proportional to under root of k, right? So lambda 1 by lambda 2, that is equal to under root of k1 by k2. So that would be our answer 2. Very simplest explanation, right? Right, very simplest explanation. Okay, so hi everyone, Jyoti, Velu, Vijit, Motivation King, hi everyone. Guys, those students who are present here right now can have the 1000+. Just press the like button, Bachaji, for this session, right? Just press the like button for this session. Moving forward, see, two identical bar, one of the paramagnetic material and other of the diamagnetic material, are kept in the uniform magnetic field parallel to it. Uniform magnetic field we are having. Parallel to it, one, we are placing the diamagnetic material, and second, we are placing the paramagnetic material. Now, according to the property of the diamagnetic and the paramagnetic material, there would be shifting into the field. There would be shifting into the field. So, this kind of the situation, if diamagnetic material is introduced into the constant field, so the field would be shift from its position. And if the paramagnetic material, so these two diagrams represent the exact situation when they are introduced into the magnetic field. So these two diagrams represent the exact situation when they are introduced into the magnetic field. Okay guys, so hope so the question number 27, it is cleared in front of you, right? So hi Abhijit, yes guys, press the like button, please press. Okay guys, moving forward to the next. Very awesome question. Now see, this is a very awesome question. By seeing this question, immediately it strikes into our mind. What it strikes? Yes, it would be about the Western Bridge. But it's not a Western Bridge. It is not a Western Bridge, guys. Guys, can we see the 100 divided by 60 is not equal to 10 by 5. The 100 divided by 60, the ratios are not equal. The ratios are not equal. So it means it is not a balanced Western Bridge, and the galvanometer is connected to the midpoint. Okay guys, the galvanometer is connected to that specific point. So in this case, guys, how to resolve this question? See, we are having this kind of the circuit. Suppose from this point, the total current is flowing is I. Here, the current is I1, and here the current is I2. Similarly, if I1 is going on to the here, and Ig amount of the current is flowing through this point. So can I say that is I1 minus Ig is flowing through this branch. I1 minus Ig is flowing through this branch. Okay guys, so this is a simple application of the Kirchhoff voltage law. It is the simple application of the Kirchhoff voltage law. Okay guys, very simple application. See guys, how I am applying? You can see this equation. V is equal to 100 I1. See, I am moving from this position, from A to B. I am moving on from this position from A to B. So 100 I1 plus 10 I1 minus I. Applying Kirchhoff voltage law from this to this loop, right? So I got this equation. From this to this, I got another equation. Right guys, and resolving this, I am having the value of the current as 6.4 milliampere. Resolving this, I am getting the value of the current as 6.4 ampere. First, you have to apply the Kirchhoff voltage law between A to B and B to C. From A to B and B to C. And next loop would be from A to D and D to C. From A to D and D to C, you will get the two equations. By resolving these two equations, we will get directly value of the current passing through the galvanometer. We will get direct value of the current passing through the galvanometer. Okay guys, so this is a very awesome question. This is not a balanced Western bridge, right? The solution might be quite long because the equation we are forming, it is very large, and it would be the time consuming process. It would be the time consuming process. Okay guys, okay, so moving forward, see, this is a very nice question. I'm talking about the question number 29. Name the diode which can act as a voltage regulator. Explain its working with the help of the label circuit diagram and draw its VI characteristics. Guys, we have to name this diode. So guys, I would represent this as the Zener diode. What is the important characteristics of the Zener diode? It works into the reverse bias. What is the important characteristics of the Zener diode? It works into the reverse bias. Right, it works into the reverse bias direction, right? So guys, some of the noteworthy points related to the Zener diode we will discuss, right? See, Zener diode is always highly doped. Why? See, between P and N, right, we are having the potential barrier. The width of the potential barrier is very high, right? In the PN junction diode, the width of the potential barrier is very high in PN junction diode. So that's why it does not constitute any current when it is connected into the reverse bias. The PN junction diode does not constitute any current when it is connected into the reverse bias because of the high width of the potential barrier. So as because of it, this Zener diode, right, it is having the very special characteristics. It is highly doped. It is highly doped with the impurity so that the width of the potential barrier decreases to the very smaller value and electrons can easily drift from one side to another side. The electrons can easily drift from one side to another side. So as because of this reason, the Zener diode is designed like that way. As because of this reason, the Zener diode will be designed like that way only. So that it should constitute the current in the reverse bias direction. So it can operate continuously without damaging the junction, and this is a symbolic notation of the Zener diode, and these are the VI characteristics of the Zener diode. Okay guys, this is, okay, see, do you know about this point? Can I say this is the breakdown voltage point, or you can say the breakdown point? Guys, this is the breakdown point. Okay guys, from this up to this point, the value of the voltage is increased to the very bit value, and suddenly after this point we are having the maximum amount of the decrease into the voltage. Okay guys, so is it clear, right? So we have named this diode as the Zener diode as because of it is heavily doped and it works into the reverse bias direction. Guys, can I have the 1000+ likes, right? Okay, so moving forward to the next question. See, the density of the nuclear matter is tremendously larger than the physical density of the material. This is as because of the Rutherford's equation. Have you heard about the Rutherford's equation, right? Okay, if I am talking about this equation, we are having like a to the power 1/3, and this value exits into the Fermi. Fermi, it means that yes, 10 raised to minus 15 meter. 10 raised to minus 15 meter. So answer for the 1 would be this equation according to the Rutherford. He was only the person who determined the radius of that specific nucleus, right? He was the person who determined the radius of the specific nucleus. Now moving forward to the next point B. The nuclear forces are not Coulombian forces. Yes, exactly. The nuclear forces are not Coulombian forces. Why? As because of the range difference and as because of the strength. right? The nuclear forces are the strongest fundamental forces. The nuclear forces are the strongest fundamental forces as because of the relative strength and as because of their range. As because of the relative strength and as because of their range. Okay guys, so answer to the second question is also clear. Now draw the plot the potential energy between the graph between the potential energy and the pair of the nucleons as a function of the distance. Guys, this is from NCERT. The same graph it is given into the NCERT and the question has been directly asked, directly put it from that specific part, right? It has been directly taken from that specific part. So guys, this is only the graph of the potential energy in terms of the mega electron volt versus the distance in terms of the Fermi. Okay guys, this is the Fermi. Okay guys, okay, this is a very simple explanation. It is given into the directly into the NCERT. Okay, moving forward to the next part. See, what are the matter waves and find the ratio of the de Broglie wavelength associated with the proton and alpha particles when both particles are accelerated to the same potential difference and with the same velocity. See, indirectly if I am talking about, we have to use the two equations of the de Broglie. We have to use the two equations of the de Broglie. What are those two equations? First of all, we will move on to the explanation of the matter waves, right? Okay, so first of all we are moving on to the explanation of the matter waves and then we will use the two equations of the de Broglie and we will resolve this question. Okay guys, see, matter waves are the central part of the theory of the quantum mechanics. Being an example of a wave particle duality, all matter exhibits the dual nature, the wave nature and particle nature, For an example, a beam of the electrons can be diffracted just like the beam of light or water wave. Matter waves are referred to as the de Broglie waves as because of their dual nature, right? They can be diffracted just like the beam of light also and from the water, like a water wave also, right? So they persist, they persist the dual nature, the particle nature also and wavy nature also, wavy nature also. Okay guys, so as because of this, right, this is an explanation. Now we are using the second question. Okay, first of all, the de Broglie wavelength when the two particles are accelerated to the same potential difference and when they are having the two wavelengths, right? So this is a very simple explanation, right? Okay, so this is the solution. When they are accelerated with the same potential difference, we are using this equation, lambda is equal to h by under root of take 2 ke by m. We are using this kind of the equation, na? Are we using this kind of equation? Yes or no? Are we using this or not? Yes. Hi, and are we using this or not? Right? Can I have the likes from your side? 1000 plus, bacha ji. Just press the like button, those who are present. Okay, guys? So, this is the equation we have to just compare for the proton and the alpha particle, right? So, it would be inversely proportional to the mass. It would be inversely proportional to the mass and I am getting the ratio of the proton to the alpha as 2. Right? So when they are accelerated to the same potential difference, the ratio would be 2:1. And when they are having the same velocity, the ratio would be 4:1. Simply two equations of the de Broglie. Lambda is equal to h by under root of 2mk. When accelerated to the same potential difference, this is the first equation, and second, lambda is equal to h by mv when they are having the same velocity. Okay guys, when they are having the same velocity. Okay guys, moving forward to the next part. See, it's a very nice question. Into the LCR series circuit, a direct question of the alternating current. See guys, what is the value of L is given? The L is given as 2 Henry, right? The capacitance is given as 32 microfarad. And resistance is given as 10 ohm. At what angular frequency the AC will be at resonance? So indirectly what we have to find the resonant frequency. So that would be at what angular frequency. So omega is equal to 1 by under root of LC. This is my direct formula. Omega is equal to, for a resonance condition we are having omega is equal to 1 by under root of LC. So first part, the omega can be given as 1 by under root of 2 into 32 microfarad. So into 10 raised to minus 6. So omega would be 1 by 8 into 10 raised to minus 3 radian per second. This is my value. Okay guys, this is my value. Second part, calculate the Q value of this circuit. So second part, it states that Q is equal to 1 by R under root of L by C. We are having the direct formula. 1 by R under root of L by C. We are having the direct formula. So it's a very simple explanation. 1 by R, R would be 10. So 1 by 10. 2 by 32 into 10 raised to minus 6. So it would be 1 by 10 into how much it would be? 4 into 10 raised to minus 3. So this is my value of the Q factor. These are the two answers, direct answers, right? We can resolve it. Okay guys, we can resolve it. Is it okay guys? We can resolve it. Okay, so this was a question number 32. Now moving forward to the another part. See, an ideal inductor of a 5 by pi Henry. See, I am saying L is equal to 5 by pi Henry and it is given as an ideal inductor is connected to the V is equal to 200 volt and 50 hertz of AC supply. So frequency that is equal to 50 hertz. See, I am using this equation. Can I replace as omega is equal to 2 pi of f? Replacing this equation, I am getting omega is equal to 100 pi. Right? So using the equation of the omega, I am getting XL that is equal to omega L. So that would be 100 pi into 5 by pi. So I am getting the value of the reactance as 500 ohm. XL that is 500 ohm. It is clear? XL that is equal to 500 ohm. Is it clear guys? Now what would be the calculate the value of the current? So value of the current that is equal to the value of the current that is equal to what? The value of the current it is given na. Okay guys, see it appears in front. Okay, so value of the current would be I is equal to V by impedance that is equal to XL. So from here we will get the value of the current. See, I am again erasing to have you the perfect solution for this, right? I am again erasing to have the perfect solution for you on this. Okay guys, so see, I am sorry for that, right? I am having again a perfect solution for you, right? Okay, see, I already solved in it. Okay, so I am erasing it, sorry for that. Okay guys, so this is a solution for you. Okay guys, the same thing I have done, right? I am getting the value of this as a 0.4 ampere, right? Okay, and IRMS value would be I0 by root 2, so I am getting 0.2 root 2 ampere. Okay, the same value is there, right? And the next, what is the phase difference between the current through the inductor and the applied voltage? How will it change a small? See, if a small resistance is connected, if the value of the resistance is very less than an inductor, if the value of the resistance is very less than inductor, so in that case the angle, the phase angle would be in between 45 to 90 and specifically it is taken at approximately 90, right? And if the L is greater, then it exceeds the 90. Okay guys, so this is a solution for that, right? The current is in this direction and the voltage is in this direction and we are having the phase by this formula, right? This is a direct formula, right? But obviously it would exist in between, right? See here, the resistance is less than L na? So in this case the phase angle would always exist between the 45 and 90. It always exists between 45 and 90. Clear? Is it clear guys? Is it clear? Is it clear? Right? So this is a very simple explanation. Now moving forward to the next part, right? Use the necessary diagram to derive the mirror formulas, right? See, for the mirror formulas guys, I would recommend you all, right? There is no person, there is no science student, right, that is not is unaware of this mirror kind of the formula. Yes, we are having this kind of the situation, 1 by V plus 1 by U that is equal to 1 by F, right, using this kind of the mirror, right? And this is the principal axis, right? Here the object is kept, right? Sorry, this is a lens. Okay, sorry, this is a lens. Okay, sorry for that, right? See, we are having this kind of the equation na. This is a principal axis. Okay, this is a concave mirror. Here the object is kept U. Here the image is formed V, and here I am getting the focal length F. This kind of the situation, right? So for this derivation I would recommend you all to see the video, right, for the mirror formula that is already existed on this specific channel. Okay guys, so it's not a big deal. The big deal is the second question, right? See, in the magnified image of a measuring scale marking lying along the principal axis, the concave mirror markings are not at equidistance. See, initially if I am talking about the reality, the markings are done at the equidistance, but the concave mirror, if I am talking about the concave mirror, it is a converging mirror. The concave mirror is the converging mirror. Okay guys, the concave mirror is a converging mirror. So whatever the final image would be formed, right, whatever the final image would be formed, that will not make those markings at the equidistance, right? That will not make those marking as the equidistance. So reason for this is, the concave mirrors are the converging mirrors. The concave mirrors are the converging mirrors. Okay guys, is it clear? Is it clear guys? Okay, so this is the answer we got. The concave mirrors are the converging mirror. That's why the markings are not at an equidistance. The markings are not at the equidistance. Okay guys, moving forward, how energy bands are formed in a crystalline solid. I am taking a very simple example of a sodium. I am taking the very single, see, more than two isolated atoms, guys, more than two isolated atoms. See, Bohr's theory is applicable only for the one single atom. If I am talking about, see, this is a nuclei and this is an electron revolving round into the ground state. So this is the isolated atom, na? This is the isolated atom, right? So Bohr's theory is applicable for this kind of the atoms only. Bohr's theory is applicable for this kind of the atoms only. But in this isolated atom, we are not having any kind of an external foreign forces. In this kind of the isolated atoms, we are not having any kind of external forces. But if I am talking about the crystalline solids, then suppose this is a nuclei, this is an electron, this is another nuclei, this is another electron, right? See, if I am talking about this nucleus, so there is an attraction between the nucleus and an electron. Here, again, there is an attraction between this nucleus and electron. But what about this electron and this nucleus? It would be the foreign force for an isolated atom. It would be the foreign force for an isolated atom. So in this case, in the case of the crystalline solids, the foreign forces are acting. But in case of the isolated atoms, the foreign forces are not acting. So as because of those foreign forces, the covalent bonds are formed. And whenever the covalent bonds are formed, there is always an electron sharing. So there is always an electron sharing. So if I am comparing the situation between the isolated atoms and this kind of the lattice structures, the crystalline solid. So in this, whatever the electron is present into the lastmost orbit, it is having only one single energy level. It is having only one single energy level. But if I am talking about, but see, this is the electron into the outermost orbit. This is the electron into the outermost orbit. Okay guys, so this is having only single energy level. Why it is having only single energy level? Because it is an isolated atom. It is an isolated atom. But I am talking about the, right, if I am talking about the crystalline solids, right, then it is having the action of the, we are having the action of the external forces. So in this case, if there are Avogadro number of the atoms into the 1 mole, then all of the atoms are having them some specific electrons into the outermost orbit. Then all of the electrons into the outermost orbit will not have the same energy level. So they will have a kind of the different energy levels, right? And that energy levels will form together and make up a band-like situation that is known as energy band. Guys, that is known as what? Energy band. Okay guys, right? So if I am talking about the 1 mole of the specific sodium, right, then we are having the 1 electron into the 3s orbit, right? If we are having the 1 electron, according to the electronic configuration, we are having the 1 electron into the outermost orbit, na, right? So in 1 mole of that, we are having 6 into 10 to 23 atoms. So all of those electrons into the outermost orbit of all the Avogadro number of the atoms, they will not have the same energy level and they will combine to form this kind of the bands, and those bands are known as energy bands. Okay guys, so this is how the energy bands are formed into the crystalline solid, and this is the diagram. Sorry for that guys, I am rubbing here. Okay, see, this is the diagram. Right? So for the donor energy level, right, in the p-type and n-type semiconductors, in one, the donor energy level is near to the conduction band, and in another, the acceptor energy level, it is near to the valence band. The acceptor energy level is near to the valence band, and in one, the donor energy level, it is near to the conduction band. Okay guys, is it clear? Is it completely clear guys? Now, moving forward to the next question, right? What is mean by the plane polarized light? A very simple and direct question and the direct theoretical explanation of the polarization. Okay guys, is it clear bacha ji? Is it clear? So an unpolarized incident and angle theta on the surface of the glass refractive index mu. The refracted and the reflected rays are perpendicular to each other. Then obtain the relationship between the mu and theta. See, obtain the relationship between mu and theta. Okay guys, see, there is a very simple, before moving on to that, let us move on to the concept of the polarization of the light. Right, what is the polarization of the light? It is a very simple explanation. I am comparing it to the day-to-day life example. See, we are having the very simple sunglasses and we are seeing towards the sun. right? So that light itches to the eyes, na? But if we are having the UV kind of the glass and we see towards the sun, then it is what we can say the very easy process as compared to the previous one. We are having the very easy process as compared to the previous one. So in that case, some amount of the light that is coming from the sun, it has been polarized. In simple form, it has been cut. It has been polarized. It means it has been cut like this way. You can see the visual in front. Okay, guys. You can see the visual in front. Okay, guys. It is. Okay, so guys, so this was now according to the Brewster's law, we are having the direct relation mu is equal to tan of P. You have heard about the Brewster's law, na? You had heard about the Brewster's law, na? See, Brewster's law states that whenever the two phenomena are going on simultaneously, the reflection and the refraction from the light, right? See, this is the incident ray. Some amount of it is going on to the reflected part and some amount is going to the refracted part, right? Refracted part. So in that case, when plane polarized, unpolarized light is incident on the polarizing angle, then the relation between the polarizing angle and this polarizing angle, right, and the refractive index is given by the Brewster's law. It is given by the Brewster's law. Okay, guys, it is given by the Brewster's law. So guys, this was the explanation now. Okay, see, next question. 35 number. Two plane polarites P1 and P3 are placed in a cross position. An unpolarized light of the intensity I0 is incident on the P1. If P2 is rotated through angle theta, like this way. Suppose two surfaces are there. If the third one is rotated with angle theta, if third one is rotated with an angle theta, and about the direction of the propagation of light, keeping P1 is fixed, plot the graph of intensity for a light versus angle, right, in which the light is transmitted by either P1 and P2. See, for this two specific situation to plot out the graph, first of all, we need the values of the intensity. First of all, we need the values of the intensity. So guys, in this case, see, intensity is directly given by this equation. I1, first of all, I1 is equal to I0 by 2. And then I2 would be I1 cos square theta. Replacing this equation in this, I am getting the value, right, okay, for the intensity of the light crossing from the second surface and intensity of the light that is crossing from the third surface. From second and third surface, we are having the direct equation for this. Okay, see now, moving forward to the very next question, right? See, yeah, it is a very simple thing. Young's double slit experiment. Young's double slit experiment, right? Okay. There is no single person, right? See, there is a single source, okay, who is unaware of this experiment. See, there is a single source, right? There is a single monochromatic source, right? It is emitting the light and we are having the two holes at the specific distance d. Now what happens whenever the light crosses this hole, right, then we are having a kind of the interference pattern here. We are having the kind of the interference pattern like this way. We are having the kind of the interference pattern, right? So as because of this interference pattern, this is the central maxima, the brightest fringe is produced. Central maxima. The brightest fringe is produced, central maxima. In short, this is what we are discussing about the Young's double slit experiment. This is what we are discussing about the Young's double slit experiment. Okay, guys. So for this, we are having the direct equation for the nth maxima. Na? For nth maxima, right? See, first central bright fringe is there. Then we are having the dark fringe first. Again, we are having the bright fringe. Again, we are having the dark fringe. Like this kind of the situation is formed. Like this kind of the situation is formed. And for the nth maxima, we are having this direct formula y is equal to n lambda capital D by D. We are having the direct formula y is equal to n lambda capital D by D. Right, guys? See, okay. So this is a briefly describe the Young's double slit experiments for the interference of the light. So guys, are you not aware of this kind of the solutions? Right? We have seen into the Young's double slit experiment, na? But what we have to discuss right now about the fringe width. This is the formula of the fringe width. Guys, this is the formula of the fringe width. Suppose if I am talking about the nth fringe. So this is the formula, right? Okay, fringe width is what? Can I say this is, suppose this is the central maxima. This is the central maxima. This is the central maxima. Now what would be the fringe width? If I am talking about this is the first dark fringe and this is the first dark fringe on the opposite side of the central maxima, right? So can I consider this as the beta fringe width? Can I consider this as a beta as a fringe width? Okay, guys. So moving forward, see, for this, if I am applying to yn plus 1, so my fringe width would be yn plus 1 minus yn. So resolving this, I am getting the formula of the fringe width. Resolving this, I am getting the formula of fringe width. Is it clear, guys? Is it clear? Is it clear? It's a very simple explanation about the Young's double slit experiment you have always seen before. Okay, guys, see now. We are having the calculation related to it. The monochromatic light of the wavelength 588 nanometer is incident from air to water interference. Air to water. Find the wavelength and the speed of the refracted light. The refractive index. See, we are having the direct solution. Suppose from air to water, the light is specifically incident with of this wavelength. Lambda is equal to 588 nanometer. Right? Now here, the velocity of the light in the air is V1. I mean, this respective medium, it is V2. Right? So we are having the direct relation between the wavelength and the refractive index. That is, if I am talking about the mu, can I consider mu as equal to C by V? Mu as C by V, and can I replace V as a lambda F? Okay, replacing this, I am getting this relation. Okay, guys, replacing this, I am getting this kind of the relation. So comparing for lambda 1 to lambda 2, right, I am getting the lambda 2 as 441 nanometer. I am getting lambda 2 as, guys, 441 nanometer. So the wavelength of the light in the air was 588 nanometer. And if I am comparing by this equation, I am getting the wavelength of the light on that specific monochromatic light into the water as 441 nanometer. As 441 nanometer. Okay, guys, those students who are present right now, can you press the like button for this session? Yes, can you press this like button, guys? Can you press this? Okay, moving forward to the next question. See, it's a very simple question. Very simple question. See, the electric dipole moment plays, see, there is a uniform magnetic field and dipole is placed. Uniform magnetic field, dipole is placed, and we are having the equation of the torque, na? Just we have to find where it would be minimum and where it would be maximum. Just we have to find where it would be minimum and where it would be maximum. Okay, guys, we are moving on. We are discussing the question number 36. We are discussing the question number 36. Okay, guys, see, if I am talking about the equation of the torque, can I say tau is equal to Pe sin theta? Tau is equal to Pe sin theta. See now, theta is an angle between the dipole moment and electric field that you all are aware of. For maximum torque, we need sin theta to be 1, and for sin theta to be 1, we need angle to be 90 degree. So in that case, the torque is maximum. In that case, torque is maximum. Now moving forward to the second case, we need an half of the maximum torque. Half of the maximum torque. So for that, if I am comparing half of the maximum torque, so Pe by 2, comparing this to the Pe sin theta, I am getting sin theta that is equal to half. So theta would be 30 degree. So for a torque to be half of the maximum value, the angle between the dipole moment and electric field should be, the angle between the dipole moment and electric field should be 30 degree. Right? The angle between the, yeah, it is very simple, Abhay, it is very simple. Okay, guys. So moving forward, see, yeah, this is a very simple question, huh? And I'm going to give you the shortcut also, right? See, two charges are placed. This is charge Q1 and this is charge Q2. They are separated by the distance 2 meter. So at what point in between them the net electric field is 0. So for that we are having the shortcut also, and we are having the long derivation also. See, long derivation is in front of you, right? So at that specific point where the electric field, the net electric field is 0, it means that because of electric field as because of the Q1, we are going to compare the electric field as because of the Q1 and Q2. This is also the very simple question. This is also the very simple question, but I am going to give you the shortcut related for it, right? This is going to help you a lot into the JEE second attempt, right? Suppose you are measuring the distance from Q1, so we are having the Q1 under root of Q1 plus under root of Q2 into L. This is my shortcut. If I am replacing Q1 as a 1 coulomb 1 whole divided by 1 plus 2. So my answer would again, it would be 2 by 3. So this is a difference between the shortcut and the long term method. So this is applicable for the electric field also, and this is applicable for the electrostatic force also. It is applicable for the electrostatic field also and electrostatic force also. Now if I am moving on to the general procedure. So at this point the net electric field is 0. So kq by x, suppose this distance is x. So can I say this distance is 2 minus x whole square? This is x, then that is 2 minus x whole square. So k into 1 by x square is equal to k into 4 by 2 minus x whole square. Replacing this, I am also getting 2 by 3 meter. Replacing that, I am also getting 2 by 3 meter. It is a very simple. See guys, this is a shortcut and this is a long cut. This is a shortcut and this would be the long cut. Okay guys, and this kind of the shortcut are applicable for the both. right? For the electric field also and electrostatic force also. For electric field also and for electrostatic force also. Okay guys, so moving forward to the next part. Derive the expression of the force acting per unit length between the two long wire. This is the direct theory of the magnetism and matter. We have seen this kind of the theory directly. Two wires are there having the current, or you can say the two wires are separated by distance d, or you can say two current carrying conductors, they are separated by the distance d, right? Okay, two current carrying conductors, they are separated by distance d. So what is the amount of the force acting between them? What is the amount of the force acting between them? So guys, in that case we are having the very simple explanation. Okay guys, we are having the very simple explanation. Okay guys, see, you have heard about the formula na, F is equal to mu 0 I1 I2 whole divided by 4 pi d. This is force acting per unit length. This is the wire 1, this is the wire 2, and current I is flowing, I1, and this is I2, they are separated by distance then d. So force acting on 1 as because of 2, force acting on 1 as because of 2 is directly given, shown by this equation. It is directly shown by this equation. Okay guys, so moving forward to the next question, right? Moving forward to the next question, derive an explanation. Okay, now we have to define the 1 ampere. We have to define the 1 ampere, right? See, we have seen the equation. The long two parallel conductors are separated as shown, right? And the electric field or a magnetic field is given by this equation, 2 pi of d, right? At any point in between the two wires, at any point between the two wires, the magnetic field is given by this equation. At any point between the two wires. Okay guys, so how to define the 1 ampere? We have to define the 1 ampere. Say this statement should be written into your supplementaries, right? Then only you are going to get the full marks, right? Because this is directly given into the NCERT book. This is directly given into the NCERT book. Okay guys, so moving forward, see, 1 ampere is defined as the value of the steady current which when maintained in the each of the two straight parallel conductors of the negligible cross section placed in the apart vacuum will produce this much amount of the force. See, we have to define 1 ampere, right? 1 ampere is the value of the steady current when this wire are having very negligible cross section, and the force per unit length of 2 into 10 raised to minus 7. The force into per unit length of 2 into 10 raised to minus 7 meter. See, area of cross section is very negligible. Area of cross section is very negligible, right? The force per unit length is 2 into 10 raised to minus 7 Newton per meter. Right? If this kind of the situation exists, then only we are able to define the value of the 1 ampere. Then only we are able to define the value of the 1 ampere. Okay guys? Okay guys? Chaliye, moving forward. Two long parallel wires, see, two long parallel wires, see, simple thing it is there. See, two long wires are there. They are having the current into the opposite direction. This is 3 ampere into the upward direction and this is 3 ampere into the downward direction. We have to find the net magnetic field at the midpoint. We have to find the net magnetic field at the midpoint. See guys, I am applying the right hand thumb rule, right? See, current is going like this way, na? Current is flowing like this way, na? So, electric field is emerging outside the board. Emerging outside the board. And from this, current is moving like this way, na? Right? Current is moving like this way. Hai na? Right? So, in this case, current is moving like here, it is moving like this way and it is emerging inside. In both of case, it will emerge inside. In both of the case, by applying the right hand thumb rule, it will emerge inside. So, the relation between the magnetic field, right, the equation of the magnetic field is given as, see, the mu 0 I whole divided by 2 pi r, r that is 6 into 10 raised to minus 2, r that is 6 into 10 raised to minus 2, but it should be multiplied by twice. So, here I am getting 2 into 4 pi into 10 to the power minus 7 into the value of the current 3 ampere whole divided by 2 pi into 6 into 10 to the power minus 2. Resolving this, I am getting the net magnetic field as 2 into 10 to the power minus 5 Tesla. This is an answer, right? This is an answer. Okay guys? Okay guys? Okay guys? Chalo, moving forward to the next question guys. Right, this was a very we have to find the magnetic field at the center. Okay guys, see, this is the schematic sketch of the cyclotron. Explain the shape of the path on which charged particle moves when the particle is accelerated. who is not aware of the device cyclotron? The cyclotron is a device that is used to accelerate the charged particles. It is having the D kind of the situation. Two Ds are placed, na? It is having the D kind of the situation. Two Ds are placed, na? Yes or no? It is having the D kind of the situation. Two Ds are placed. Right? First of all, the electron is released from this part. After crossing up the 1D, it has been accelerated. So the radius of the path will increase. Again, after covering the entire round, again it will be accelerated. So the radius of the path will increase. So in this way, the radius of the path will increase and the charged particle is continuously accelerated by means of this device. Right? The charged particle is continuously accelerated by means of this device. So guys, this is a schematic diagram of the cyclotron. You all are aware of also and aware of this also, and this has been directly given into the NCERT. Right? The important question is this one. To convert the B part of the question, to convert a given galvanometer into the voltmeter, range is 2 volt. We have to convert the galvanometer into the voltmeter. We have to convert the galvanometer into the voltmeter for the range of 2 volt. V and V by 2 volt, ranges of 2 volt, V by 2 volt and V volt. Resistance are R1, R2 and R3 for 2 volt. If you want to convert the galvanometer into the voltmeter for 2 volt, resistance needed is R1. Resistance given is R1 for V volt, R2 and for V by 2 we are having R3. So ohm respectively are required to be connected in series with the galvanometer. Obtain the relations between R1 and R2 and R3. Suppose if you want to convert the galvanometer into the voltmeter, so it is for sure with the galvanometer. See guys, suppose this is a galvanometer, the resistance is connected into the series. The resistance is connected into the in series. Resistance is connected in series to convert this galvanometer into the voltmeter. Why? By using this galvanometer, we are able to measure the potential difference between the 2 points also. Okay guys, so in this case, suppose I need the voltmeter of V volt, sorry 2V volt, then resistance would be R1. Suppose I need the resistance of potential difference of V, then resistance is R2. Suppose I need a potential difference or V by 2, then resistance is R3. These three kind of situations are going on, right? And just we have to find the relation between 1, 2 and 3. It means R1, R2 and R3. Very simple explanation. Okay guys, very simple explanation. Okay guys, so those students who are present here, can I have the 1000+ like? Guys, just press the like button for this. Okay guys, so moving forward, see, let the resistance of the galvanometer be Rg, max current carrying capacity. Suppose if I am talking about the V, then it would be IRG plus R1 because they are connected in series, right? They are connected in series, na, so the equivalent resistance would be Rg plus R1, Rg plus R2, Rg plus R3. First situation, Rg plus R1, Rg plus R2, Rg plus R3. Similarly, if I need for V by 2, Rg plus R2, resolving 1 and 2, I am getting the relation between the R1 and R2. I am getting the relation between R1 and R2. Now see, suppose I need for the 2 volt. So can I move on for this relation, that is Rg plus R3, right? So can I consider this as equation number 1? So by 1, 2 and 3, right? I am getting this relation, R3 is equal to 3R1 minus 2R2. R3 is equal to 3R1 minus 2R2. Okay guys, okay guys, okay guys, okay guys, yes or no, yes or no, yes or no, yes or no. Okay guys, so guys, so this was a very simple thing guys, right? So this was a solution for your specific answer, right guys? So I think we discussed the entire paper of the today's boards, and first of all, thanks, best of luck to you all, right, for the upcoming papers, and hope so by discussing these things, the paper, you have rectified the entire paper. You have rectified the entire paper. Okay guys, you have rectified the entire paper. Okay guys, so this would be the end part, right? So hope you like this session a lot. This was a discussion, right, on the boards paper, today's boards paper. Okay guys, so this is Indrajit Singh signing off from the desk, Bachcha ji. This is Indrajit Singh again and again for the upcoming boards paper. Again and again for the upcoming board papers, guys. I am saying upcoming board papers, all the best and best of luck to the each of the students. Prepare well, give your best. Okay, guys. So this is Indrajit Singh signing off from the desk. This is Indrajit Singh signing off from the desk, bacha ji. So bye. Namaste and Sat Sri Akal from my side. Bye everyone.